the sensor attached on,
attached to the platform.
and the sensor that take the photograph.
The image, yes.
The platform contains more than one sensor.
Yes, yeah, okay. Yes. Platform may contain more than one sensor. Platform, the sensor is attached to the platform. So platform is what? It is something which provides stability to the sensor. So the sensor is attached to the platform, and the sensor will not work on its own if there is no platform. It has to be attached to the platform, and then only the sensor will become stable and it will be able to do its work. Now, how many different types of platforms are there? Yes,
In the space,
yes.
the ground and the air.
In the air. So means you can have a space-based platform, and the sensor which is attached to the space-based platform will be a space-based sensor. Okay. Then you have an air-based platform and sensor, and similarly you have a ground-based platform and a sensor. Can you give me an example of a air-based platform and sensor? Anyone else? I know you know the answer. Okay, tell me.
Airplane.
Aeroplane. So aeroplane is the sensor or it's the platform? It's the platform. And if you attach a camera to that aeroplane, it will be the sensor which will take the images. What about the space-based platform? Satellites are space-based platform. So satellite is not a sensor. Satellite is a platform. To the satellite, you have the different sensors which are attached, which are taking images of the Earth's surface. And what about the ground-based platform? Any example? Yes. No, drone is in the air.
Car.
The speed camera, for example, it is attached to the pole, or maybe sometimes. Yeah, the traffic cameras. They are an example of the ground-based platform and sensor. Now each sensor has its own advantage and disadvantage, but mostly when we are talking about remote sensing of the Earth, we are mostly dealing either with air-based platform and sensor, or these days we are dealing with the space-based platform and sensor. So we are talking about satellites and satellite images. So satellite is what? It is a space-based platform, a platform which is in the space. So it says here that the sensor must be on a stable platform away from the target or surface being observed. Then only, if it is attached to the surface target being observed, then it is not remote sensing. So there has to be some distance between the target and the sensor. Then only it will be called as remote sensing. Okay. So you have the different kinds of sensors and platforms shown here. Okay. Ground-based sensors, they are used to record and collect detailed information about the Earth's surface. Like you have, for example, this pole is there, and to that pole, this sensor is attached, which is getting information from the ground. You have these trucks, and on the truck you have this camera or the sensor which is attached. Now, since it is close to the ground surface, the area covered by these sensors are small, but it is in detail because it is close, so you can get very high resolution images. So the data collected by ground-based sensor is used to compare the data collected by other sensors like satellite to understand the surface features in more detail. So you have some information from satellite sensor that is from far away. If you are getting confused or if you are not sure about what you are seeing from the satellite image, you can cross-check with the ground-based sensor also, because the ground-based sensor is close to the surface, so the images which it takes are in more detail. One advantage of this type of sensor is that atmospheric disturbances are absent. Means if the weather is bad, if it is raining, if the wind is strong, if there is dust storm, it will not be very difficult to do the remote sensing because the sensor is very close to the ground. So atmospheric disturbance will not affect the quality of image which you take to a high degree. Means only small disturbances may be there. Okay. But the disadvantage is that it's very close to the ground, so you get only a small area covered by this sensor. Then you have the air-based sensor. You have the aircraft, or you have the hot air balloon. Sensor is attached to the aircraft. In this case, maybe a camera is attached here, or you have the sensor which is attached here. Okay. The aerial coverage will of course be more than the ground-based sensor because it is high, maybe a few kilometers in the atmosphere, so it will cover a bigger area. But the problem is that these kind of sensors or platforms are sensitive to atmospheric disturbances. If it is raining, if it is cloudy, if it is windy, then the balloon won't work, the aircraft will be, the visibility will be reduced, you cannot see clearly, so the quality of image will not be good in this case. Okay. Then the most important one is the space-borne sensor. So you have the satellite, and on the satellite you have the sensor which is attached. Okay, and these remote sensing satellite, they are giving you information about the Earth surface. Okay, satellite-based sensors, they are the most efficient and widespread. Most commonly used type of images are from the satellite images. They can give global level coverage, but it is costly. Okay, okay, it is costly, but to launch the satellite, to make the sensor, it is costly. But once it is there, the data which it is giving, providing you, most of the time you can get the data freely from their respective websites. You just can go there and download the data. So it's almost free. Okay. Yes, of course, some satellites which are providing you very high resolution data, like Worldview or GeoEye, they provide you with very high resolution data, spatial resolution. So that data you cannot get for free. You have to purchase, you have to buy from the agency. But like Landsat or Sentinel or MODIS or Aster, these data you can download from their website. So this is the same thing, which it shows the three different types of sensors and the platform: air-based, space-based, and the ground-based. Then, as we told, we will be focusing mostly on satellite remote sensing, or we will be talking about the sensors and the platforms which are present in space. So when we are talking about that, we need to understand some of the features of the satellite, okay? Satellite characteristics, because when we talk about satellite, we are talking about remote sensing from the space. So when we are talking about satellite, two most important things related to satellite is the satellite orbit and the satellite swath. So we will see what is the two. Okay. Although ground-based and aircraft platform may be used, satellites provide a great deal of the remote sensing imagery commonly used today. Most of the images which we are using for remote sensing purposes, they are mostly coming from the satellites. Okay. Satellites have several unique characteristics which make them useful for remote sensing of the Earth's surface. Now, first thing is the orbit of the satellite. What is the orbit? Orbit is the path followed by the satellite to move around the Earth's surface. Means you have the Earth's surface, okay, this is the Earth, and suppose this is the satellite. That satellite is moving in a fixed path around the surface of the Earth. Okay, it is moving in a fixed path. So the path which the satellite takes to move around the Earth's surface, that is called as the orbit. Okay, satellite orbit. So satellite orbit is very important depending on our application. For what purpose we want to use the remote sensing images, based on the purpose we will choose the satellite orbit. Not all satellites will be in the same orbit, they will be in different orbits. Okay. So that is what it is written here. Satellite orbits, they are matched to the capability and objective of the sensor they carry, depending on the purpose of the satellite or the sensor on the satellite. We choose the orbit of the satellite. So orbit selection can vary in terms of altitude, their height above the Earth's surface, and their orientation and rotation relative to the Earth's surface. So means you have the Earth's surface, okay. So depending on the altitude, height, okay. Some satellites may be placed in this orbit, some may be in this orbit, some may be in this orbit. So depending on the height above the Earth's surface, you can have different types of orbit, and depending on the relative motion of the satellite, means the Earth's surface is there. Some satellites, they move north to south along the from pole to pole, and there are some satellites which move from east to west along the equator. So some satellites move in the east-west direction, some satellites move in the northwest direction. So one way is based on the altitude, how high the orbit is situated, how high the satellite is situated. So this is one way of classification of the satellite orbit, and the second way is in respect to the orientation, whether the movement is pole to pole, north-south, or whether it is east to west along the equator. Now, depending on the height above the surface, you can have three main types of satellite orbits. Okay, it's written LEO, MEO, and GEO. Okay. Now, what is LEO, what is MEO, and what is GEO? Starting with the GEO. GEO means GEO means geostationary Earth orbit. Okay. MEO means middle Earth orbit, and LEO means low Earth orbit. So, as the name indicates, if you go back to this one, okay, you have LEO, MEO, and GEO. So, GEO is the farthest from the Earth, LEO is the closest to the Earth, and MEO, the middle Earth orbit, is in between the LEO and the GEO. Okay. Now, in which of the three satellite, you have one satellite in LEO, one in MEO, and one in GEO. Which will give you the biggest coverage? GEO, because it is very far away from the Earth. So you see the coverage, almost half of the Earth you are covering with the GEO. But if you talk about LEO, it's only a small portion of the Earth. So that means if you have three satellites in the GEO orbit, geostationary Earth orbit, you can cover the whole Earth. Okay, but as you move closer, as you move to MEO or LEO, you need more number. Sometimes, for example, in MEO you may need at least 20 satellites to cover the whole Earth. If you talk about LEO, you will need more than 20 to cover the whole Earth. So, based on the height or the altitude from the Earth's surface, you have three types of orbit: GEO, MEO, and the LEO. Okay. Now, if you talk about, we talk about one by one, each of them one by one. So, geostationary orbit, the height of the geostationary orbit is 36,000 kilometers above the Earth's surface. Very precise, if you want, it is 35,786 kilometers above the Earth's surface. Now, look at this carefully. The altitude, it's written only one value is given. Okay. If you go to the MEO, you have a range which is given. 5,000 to 20,000 kilometers above the Earth's surface. And if you go to the low Earth orbit, you again have a range from 500 to 1200 kilometers above the surface of the Earth. But for GEO, we have not provided a range. We have given only one value. Why one value? Because this is a geostationary orbit. What do you mean by geostationary orbit? If you put the satellite in the geostationary orbit, the satellite position with respect to the Earth's surface will always remain the same. The satellite is moving, as the Earth is moving, the satellite is also moving. But the rate at which the satellite is moving and the rate at which, the speed at which the Earth is moving is the same. Okay? So the satellite always appears in the same position. Means if you are able to see that satellite with a telescope or something and you see that it is there from where you are standing, it appears in that position in the sky. So any time of the day you observe that satellite, it will be in the same position. It will appear stationary with respect to you. So that is why the word geostationary, and that thing will be possible only when you send the satellite at this altitude, 35,786 kilometers, and at that altitude when you match the speed of the satellite with the speed of Earth's rotation, the satellite will appear stationary. If you change the altitude, then you cannot match it. That means you will not get the result, same result. The satellite will not be geostationary. Okay, so geosatellite, they match the rotation of the Earth as they travel, so they remain above the same point on the ground. They do not change their position with respect to where you are standing on the Earth. Now hundreds of geosatellites are in orbit today, traditionally delivering services such as weather data, TV broadcast, and some low-speed data communication. Now, it says that the TV broadcast satellite means if there is a match in Jeddah, you can watch football match is taking place in Jeddah, you can see the match on television in Riyadh. Now, how do you see that? So you have the television crews there, the video people who are making covering the match. The data is sent to the satellite, and from that satellite the data is transmitted to you, and you are watching that match on your television screen. Now, it says that the TV broadcast satellite, they are mostly placed in the geostationary orbit. Okay. Now, all of you must be having this what you call dish antenna on your. Now, that dish antenna is receiving signal from the satellite which is there in the space. Now, do you change the position of the dish antenna every time, or it remains fixed? It remains fixed until unless if there is a strong wind or some problem is there, then you will adjust. But otherwise, it is in the same position. You don't have to change the position every time. Why? Because it is receiving signal from a satellite which is in the geostationary orbit. That means the dish antenna is all the position of the satellite with respect to the dish antenna never changes. It remains the same. As the satellite is moving, the Earth is also moving, so it is continuously in communication with your dish antenna. If it was not in the geostationary orbit, then what will happen? You will have to keep one person on the roof. He will every time he will be changing the position of the antenna so that you get the signal. So that is not practical. It means one time the satellite is here, the next time the satellite moves there, then it is there, and then it is lost. So it's not practically not possible. So therefore, for this reason, all the satellites which are used for for television broadcast, they are placed in the geostationary orbit, so that the position of that satellite remains fixed with respect to your position. Okay? And also the weather monitoring satellites. Why the weather monitoring satellites are placed in the geostationary orbit, we will see that later on. Okay? Then coming to the medium Earth orbit, or which we call as MEO. MEO has altitudes between 5,000 to 20,000 kilometers. It is in between the low Earth orbit and the geostationary orbit. And MEO satellites, they are mostly used for GPS, or instead of GPS, we use the word GNSS. What is GNSS? GNSS stands for Global Navigation Satellite System. Okay. Now GPS is a part of GNSS. GPS is the oldest navigation satellite system, and this is a trademark for United States. Means the GPS technology, it belongs to United States. But now there are other countries which have their own navigation satellites. So, for example, you have GLONASS. Okay, GLONASS, it belongs to Russia. Okay, USSR, and then you have Galileo. It belongs to Europe. Okay, the European Space Agency. It owns Galileo, and then you have. I am not sure about the spelling. Beidou. It belongs to China. Okay. Now they are same thing. They are all navigation satellite. They are helping you to determine your position on the Earth's surface. Okay. So, and GPS is also one of them. So, like since GPS was the oldest navigation satellite, most of the time we use the word GPS, but actually it is the global navigation satellite system, and GPS is a part of GNSS. Galileo is a part of GNSS, Beidou is a part of GNSS, GLONASS is a part of GNSS. And each of them have, so like GPS, it has around 31 satellites. Galileo, I think around 24 satellites are there. Beidou, I think around 27. And somewhere between 25 to 30 satellites for GLONASS. Now all of these satellites, all of these global navigation satellites, they are placed in the middle Earth orbit. So the middle Earth orbit is specifically reserved for the navigation satellite. Normally no other satellites, they are placed in the medium Earth orbit. It's only the navigation satellites. Okay. Then you have the third orbit, which is the low Earth orbit. Its altitude from the surface of the Earth ranges from 500 kilometers to 1200 kilometers, and since it is closest to the Earth's surface, so you have the maximum number of satellites which are placed in the low Earth orbit. So LEO is densely populated with thousands of satellites in operation today, and they are mostly used for science, imaging, studying the natural resources on the Earth's surface, monitoring the Earth. All the studies related to the Earth resources, which is done using remote sensing, those satellites, they are all placed in the low Earth orbit. So, if you look at the number of the satellites which are there in the different Earth orbits, so you have the GEO, okay, you have MEO, and LEO. So almost 84% of the total satellites, they are placed.
About Saptium satellite in GEO.
Which satellite?
Saptium.
Except in LEO. This one. Okay. All the Landsat, Sentinel, SRTM, Aster, all of them, they are placed in the LEO, low Earth. Okay. So most of the satellites, they are in the low Earth orbit. Then it is followed by the GEO, and the minimum number of satellites, they are in the MEO. And why the least number of satellites are in MEO?
It's only used
It's,
for this.
yes, it's only for the navigation system. So that is why few number of satellites are in the MEO, but most of them maximum in LEO and followed by GEO, and then you have the MEO. So it gives you the current information, the latest information. You can see you have the three types of orbits which are mentioned there. Okay. LEO, MEO, and GEO, and it says that you see the numbers, maximum numbers around 3,300 satellites in the low Earth orbit, which constitutes around 84% of the total satellites which are present in the space. In the MEO, there are only about 129 satellites, and it is about 3.2% of the total satellites which are there. And in the geostationary orbit, you have around 481 satellites, which is around 12.1% of the total satellites which are functional at present. So, low Earth orbit is the most densely populated, most number of satellites are there, and medium Earth orbit, it has the lowest number of satellites. The reason for that, because it contains only the navigation satellite. So any other information you want, if you click on the orbit, it will give you also the information about which kind of satellite is there in that particular orbit. So like if you click on any orbit, so that information about that particular, the satellite which is in that particular orbit, you will get the information. Okay. So if you can just type in ISRI satellite map and you get this website, and if you want some information where the other satellites, which are the main type of satellites, all that information you can get from it. Now coming back to the geostationary orbit, okay. Satellites at very high altitude which view the same portion of the Earth's surface at all times, they have geostationary orbit, and that means the position of the satellite is fixed with respect to the position on the Earth. So these geosatellites, stationary satellites, they have approximately are at an altitude of 36,000 kilometers from the surface of the Earth, and they revolve at a speed which matches the rotation of the Earth. So that is why they move in the same, means they appear stationary with respect to the Earth. You can see here, for example, is the geostationary orbit, and you see the satellite and the rate at which the satellite is moving and the Earth is moving is the same, and the same point is being covered all the time. Okay, so this is the geostationary orbit. This allows the satellite to observe and collect information continuously over specific areas. Weather and communication satellites commonly have these types of orbit. Now, television broadcast, we saw that it is in the geostationary orbit. Now, why weather satellites are also mostly placed in, means weather satellites you can have in other orbits also, but most of the time they are placed in the geostationary orbit. Now the reason for that, weather changes very quickly, okay? Like in the morning it may be cloudy, in the afternoon it starts to rain, before Asr maybe the sun is out again, in the evening time there is dust storm, everything is possible. Weather is changing very quickly. Now, if you have a satellite which is placed in an orbit other than the geostationary orbit, it will take images of the Earth's surface, but there will be a, means for the same area, the images may be separated by a few hours. Like you have one image for the area today, now, and another image say after 10 hours. So there is a big difference. 10 hours is a big time. And in 10 hours, weather can change very quickly, especially if there is a cyclone, if there is a strong dust storm, then in 10 hours, many things can change. So for weather monitoring, we require images which are very close to, means 10 minutes or half an hour difference is there. So you have one image from now, another image after 10 minutes, then another image after 10 minutes. So that way, monitoring and forecasting of the weather phenomenon, it becomes very easy. You know what was happening 10 minutes before, you know what is happening now, and based on the past, you can also predict the future. You can forecast the future, how the weather is going to change. So that thing is possible only when the satellite is placed in the geostationary orbit. The satellite is continuously looking at the same place. So it takes one picture, one image now, another image, because it is at the same place, it can take another image after 10 minutes, then another after 10 minutes, and so on. It is because it is not moving. If it is moving, then it will take some time to go around the earth and come to the same place. So the time it takes for the satellite to reach the same place, it may vary. It may go up to 6, 7, 10, 12 hours. So this, if you have a weather image from now and another image after 10 hours, then it's a long time for weather monitoring. You will not be able to do the monitoring properly. So for weather monitoring, we need images which are spaced very close to each other. I mean, the time difference between the images should not be too high. Okay, so that is the reason, to minimize the time gap between the acquisition of images. The satellite, the weather monitoring satellites, they are mostly placed in the geostationary orbit. Okay. Due to their very high altitude, and some geostationary weather satellites can monitor weather and cloud patterns covering an entire hemisphere. Almost half of the Earth can be covered by one satellite, one geostationary satellite. And if you have 3 geostationary satellites, you can cover the whole Earth. Okay? Okay, so based on the altitude of the satellite from the Earth's surface, you had 3 types of orbits: geostationary orbit, the middle Earth orbit, and the low Earth orbit. Now based on the, and then you have to remember that all the second classification is based on the orientation of the orbit with respect to the Earth. The satellite may be moving in the east-west direction, okay, or it may be moving in the polar direction. So all the geostationary satellites, they are moving in the east-west direction. They are along the equator, okay. Geostationary orbits, they are not along the pole, not from North Pole to South Pole, no. They are mostly in the east-west direction. Slight tilting can be there, means either it's almost parallel to the equator, or maybe there is slight, like this one, slight inclination is there, but more or less it will be in the east-west direction. The other type is the sun synchronous or polar orbit. Okay, the polar orbit means it is moving from pole to pole, North Pole to South Pole, then again South Pole to North Pole. Now these satellites, they are also called as sun synchronous orbit. Okay. Now what do you mean by sun synchronous? That was geosynchronous or geostationary. The satellite was synchronized with the movement of the Earth. Means as the Earth is moving, the satellite is also moving. So the position of the satellite does not change with respect to the Earth. Now this one is sun synchronous. The position of the satellite is synchronized with the timing of the sun. It is synchronized with the sun. So like if 10 o'clock in the morning, if the satellite is in this position, next day again at 10 o'clock, at another place the satellite will be in the same position. At 2 o'clock the position will change, at 5 o'clock the position will change, but the position of the satellite at 5 o'clock today, it will be the same position at 5 o'clock the next day. Okay, so that means the movement of the satellite is synchronized with the sun, timing of the sun. So some satellites, they are designed to follow a north-south, pole to pole direction, which is called as polar orbit. These satellites cover the local time regularly. Okay, means since it is in the polar orbit, okay, you have the satellite which is at 10 a.m. today over Riyadh. Tomorrow at 10 a.m. it will not be over Riyadh, it will be at some other location because it is not a geostationary satellite. If it was geostationary satellite, it will always be in the same position. No, but in this case, the position is changing, but at 10 o'clock, whether you are observing the satellite from Riyadh or at 10 o'clock you are observing the satellite from Jeddah, the position of the satellite will remain the same. Okay? At 2 o'clock the position will change, and at 2 o'clock it will be the same position for Riyadh, it will be the same position for Jeddah. Now what is the advantage of that? The advantage is that if the sun is at the same position every day when you are taking the image of an area, it makes it easier to compare the image, because every time you have the same amount of light on the image. Means suppose you have an image of Riyadh, one image you have from today which was taken at 10 a.m. in the morning, and you have another image of Riyadh which was taken at 5 o'clock in the evening. Now at 5 o'clock in the evening the sunlight will be less because it is evening time. At 10 o'clock in the morning the sunlight will be more. So there you will find a difference in the image, means based on the amount of light. So if you want to make some comparison between the image, it may be difficult because you don't have the same amount of sunlight. Okay, but if you have an image of Riyadh which was taken at 10 a.m. today and another image of Riyadh after say 1 week, and that was also taken at 10 a.m., then that means you have the same amount of light, the same intensity of light falling on the city. So comparison between the two images becomes easier. So this is the function of the sun synchronous orbits or satellites which are placed in the sun synchronous orbit. At any given latitude, the position of the sun in the sky as the satellite passes overhead will be the same within the same season. Okay, means you have this earth and you have the equator and you have these lines of latitude and you have these lines of longitude. Now the satellite, say at this position it was at 10 a.m. in the morning. Okay, the position of the satellite will change, but again at 10 a.m. in the morning it will be in the same latitude. Okay, the longitude there will be displacement, it will be at another location, but at 10 o'clock in the morning the position of the sun with respect to the satellite will be the same, and say after 5 days it comes to the same position, and at this same position it will be at the same time at 10 a.m. So that means the amount of light which you get in the image will be the same. So if you have two different images from two different days, it will be easy to compare. Why? Because in both the images the sun is at the same position when the image was acquired. So this is the advantage of using a sun synchronous orbit. Okay? This allows consistent illumination condition when acquiring images of specific season over successive years. Now this is the difference between the two types of orbits based on the orientation. What kind of orbit is this one? This is the geo, because it is moving in the east-west direction. And this one is the sun synchronous or the polar orbit. Not all satellites which are in the polar orbit will be sun synchronous. Some may be sun synchronous, some may not be sun synchronous. But all the sun synchronous satellites, they will be in the polar orbit. Okay. Now you see the Earth is moving in the east-west direction. It is moving like this. So the polar satellite, as it moves north-south, the Earth is also moving by that time. So every time you see it is covering a new area. Okay, you see the white lines, it shows the area the satellite is covering. So as the satellite moves around the sun, if the Earth was fixed, then what will happen? It will be covering the same position again and again and again and again. But in this case, since the sun is moving, every time it makes a circle around the sun, it is covering a new area. Yes? And in the geostationary one, it is covering the same area, but since the satellite is very far away from the Earth, it is almost covering, means half of the area, half of the Earth is being covered by this satellite. So this is about the orbit. Orbit once again can be classified based on two things. First is the altitude, height above the surface of the Earth. So you have the GEO, MEO and the LEO, three kinds of orbit: geostationary Earth orbit, middle Earth orbit and the low Earth orbit. And based on the orientation of the satellite with respect to the Earth in the direction in which it is moving, it can be, again it can be geostationary. All the geostationary satellites, they are moving in the east-west direction. And then you can have a polar orbit or a sun synchronous orbit where the satellites, they are moving in the north-south direction. Okay. Then you have the second characteristic of the satellite, which is called as the swath. What is the orbit? Orbit is the path which the satellite takes to move around the Earth's surface. Swath is the area which the area which the satellite covers, the area on the Earth's surface which is covered by the satellite as it moves, that is called as the swath. So most of the remote sensing satellite platforms today are in near polar orbits, which means that the satellite travels northward on one side of the Earth and then southward on the second half of it. Okay? These are called as ascending paths and descending paths. Ascending means go from low to high. Okay? So when the satellite is moving in this direction, north to south. Okay? So when the satellite is moving from south to north, south pole to north pole, it is going up. So that is called as ascending path. When you go up, that is called as ascending. And in the other direction, it is coming from the north pole, north direction to the south direction. So what it is doing? It is going down. So going down is descending. D for down, D for descending. Descending means to go down, ascending means to go up. So on one side you have the descending path, the other side you have the ascending path. Ascending path means satellite is moving from south to north, and descending path means satellite is moving from north to south. As the satellite revolves around the Earth, the sensor sees a certain portion of the Earth's surface. So the area imaged on the surface is called as the swath. Means you have the sensor, and sensor is seeing this area, for example. Okay, so this is the swath of the satellite. So where will be the swath bigger, in the geostationary orbit or in the low Earth orbit? In geo, because it is far away from the Earth, so it will cover a very large area. The swath width will be larger for a geostationary satellite. For satellites which are in the low Earth orbit, swath width will be small, depending on how high or how low they are. Okay. Imaging swath for space-borne sensors generally vary between tens and hundreds of kilometers. For example, if you download a Landsat image, it is like 185 kilometers by 185 kilometers. Means one image, if you download, it will be covering 185 kilometer in the east-west direction and 185 kilometer in the north-south direction. So the area is huge, which is covered. And if you have like weather monitoring satellites, some of the weather monitoring satellite, one image may cover maybe 3,000 kilometers by 3,000 kilometers. So swath width is very large for geostationary satellites because they are far away from the Earth's surface. As the satellite orbits the Earth from pole to pole, its east-west position would not change if the Earth did not rotate. If the Earth was fixed and the satellite is moving from north to south, then every time it will be covering the same area. But the Earth is moving. So since the Earth is moving in the east-west, the satellite is moving in the north-south direction. So every time it is
Cover a new area.
covering a new area. And then after some time, what will happen? It will cover whole area, and then it will go back to the area which it covered for the first time. Okay. However, as seen from the Earth, it seems that the satellite is shifting westward because the Earth is rotating from west to east beneath. This apparent movement allows the satellite swath to cover a new area with each consecutive pass. As it completes one pass, the second pass when it makes, the Earth has already moved, so it will cover a new area. Then again a new area, again a new area, and finally it will come back to the original path where it took the first image. Okay. So this will be possible only in the polar orbit. This is if you put a satellite which is moving in this direction, can you cover same area? No, because the Earth is moving in the same direction and the satellite is also moving in the same direction. So it will cover only a small part of the Earth, and the other part, this part and this part, it will not be covered. But since you have the satellite in the polar orbit, as it moves, the Earth is also moving, so every time it is covering a new area. Now this brings us to the orbit cycle. Means what is the orbit cycle? It starts with any randomly selected path in a satellite orbit. An orbit cycle will be complete when the satellite retraces its path, passing over the same point on the Earth's surface directly below the satellite, which is called as the nadir point, for a second time. For example, the satellite came over Riyadh and it took an image of Riyadh today. The next time it took the image of Riyadh from the same position, it was say after 10 days. Okay, same image, only the date has changed. So that means what is the orbit cycle for that satellite? 10 days. Means after 10 days it will retrace the same path. So that is called the orbit cycle. Means you have an image of Riyadh, you have another image of Riyadh, you may have another image of Riyadh, you may have another. But these are not the same images. If you are talking about only this image, you have one image from today, and the same image if you have after 10 days, then that means the orbit cycle is 10 days. Okay? So we are talking about the same image. It may take another image from here, but this image and this image, they are not the same. They are different images. So we are talking about the same image. So if you have the satellite takes one image today and another image of the same place, it retraces the same path and takes another image after 10 days, then in that case, the orbit cycle will be 10 days. Okay? And you have something called nadir point here, means you have the sensor is there on the satellite, the point directly below the Earth's surface. That is called as the nadir point. Means the satellite, it can look like this also. It can look on this side also. Okay, but here it is not directly above the Earth's surface. Directly above the Earth's surface is only in this position. So this position of the sensor or the satellite, when it is directly above the Earth's surface, that is called as the nadir point. Okay, the exact length of the time of the orbital cycle will vary with each satellite. It will depend from satellite to satellite, and also it will depend with the speed of rotation and also the altitude of the satellite above the surface of the Earth. Okay. So I think we will stop here and we'll continue with this in the next class.
Thank you.